right, at the end of class today, we were talking about this example from the worksheet 3A and looking at this series, trying to compare to the ones in the box to see which it most resembled. And everybody picked out, oh yes, cosine. This looks like a cosine equation. Because you've got the 2n factorial and the x raised to the 2n power, or something raised to the 2n power. And we talked about how if I just didn't have this 36 to the n down here, then it would be exactly that function, but instead of cosine x with an x in the formula, this is actually cosine pi with a pi in the formula. And cosine pi, of course, is -1, so we would get a number answer. But that's too easy, and that's not actually the problem as it was stated. And I kind of said we have to deal with that 36 to the n, but I didn't specify how. So let's go back and figure out what does 36 to the n do to this problem, how does it change it, and what do we do with it. When you have something else raised to the n power, it really wants to, it can't be part of the -1 to the n. That can only be -1 to the n. That's just the alternating term. So it's really got to be part of the x piece. It's just a different x than what you expected. So let's rewrite this as the sum from n equals 0 to infinity, the -1 to the n. We know we have a 2n over 2n factorial, and then the stuff we have left is pi to the 2n over 36 to the n, and I want this whole piece to equal something raised to the 2n power. I want to figure out what that something is. Okay, well, for starters, I noticed that the denominator is not raised to the 2n power. I would like it to be. So what could I do to make 36 something raised to the 2 power? Well, it's nice here that 36 is a perfect square because, let me rewrite all this, 2n factorial. I could rewrite as pi to the 2n over 6 squared, 6 squared is 36, raised to the n power. When we raise a power to a power, it's you multiply the power, so I get to the 2n power. And so this is really the sum from n equals 0 to infinity, I keep writing this, over 2n factorial of pi over 6 raised to the 2n power. So the x to the 2n power in my formula, x is pi over 6. This is equal to cosine of pi over 6. And of course we all remember from our handy dandy unit circle that pi over 6, the cosine value is √3/2. So here's a problem evaluating a series. You're given a summation notation. You're supposed to recognize which of the Maclaurin series it looks like from the table, and then once you turn it into the Maclaurin series, you figure out what your x value is. You're supposed to be able to get a number answer to these types of questions. I hope that helped.